developer at Idealista. It's like a real estate directory. We have presence in Spain, Italy, and Portugal. I'm an open source software enthusiast. I'm a Pythonist and Django out, been working with Python and Django for more than 10 years. And I'm trying just to tame gophers, if you know Golang. I have a weird hobby. I like to reverse engineer in Android applications on my spare time. But I also have some normal hobbies, such as cooking and reading. And you can just reach me via Twitter or email at any time. Just feel free to send me a message. So I have this comic strip from XKCD. And it pretty much defines the problem that we're going to try to solve. So it's about someone who builds a data pipeline, but if he's not sure that if it's going to collapse at any moment. When I spot this comic strip, I just thought that this was mandatory. I needed to add this to the Airflow talk. So in the beginning, there was cron. We might have a pipeline that we have just set up using cron. And here we have 3 different steps. The first step is just some data gathering process. And it starts at 10 p.m. Then we have any kind of ETL process. And we assume that by midnight, the data that we need for processing the input, it's already in place. And then we have a report step that happens at 2 in the morning. And of course, we assume that the ETL hasn't properly by that time. And OK, we think let's just don't have that much spare time, because we know that the gather data step just takes 1 hour, and we can do it in much quicker. And we're just happy with that. But we need to check what problems could arise from that. So imagine that the second step fails. It happens. Now, we don't have any context about what will happen with the report process, because, well, it will just not report nothing or just give an error. So we're not happy with that situation. Or imagine that the first step takes longer than we expected, as we might be moving more data or whatever, and the process just takes longer, so it just overlaps with the second step. And of course, we don't know anymore about what the 2 other steps, how they are going to react to that change. So I call this cron hustle. So we just think about using cron for automating everything. And there are lots of problems that we have to think about while using cron, such as how do we manage dependencies between those tasks? In the previous example, we have some, we have overlap. On the second example, we have an overlap due to the first step taking longer than we thought. So we have to manage dependencies between them. If we need the output of the previous task to run our task or step, we have to take care of that. What about failure handling? What if any of those steps fails? Do we retry the step? We don't also know how to handle error notifications. Do we have metrics from all those steps? Pretty much, we don't have visibility about what happens in each of those steps. And well, about unified logs, each step might be done even by different teams. So we can just be safe about what will happen. And if you have at any time in your life tried to do a distributed cron, it's scary. So if in your team you are maintaining a calendar of batch jobs and you're always asking yourselves, what happens if whatever of those problems, every day is a new adventure, pretty much. So every day, okay, this process has an error, and the next step or process didn't run okay because we lack the data, whatever. So you need to meet Airflow. That was a good animation. So overview of Apache Airflow. It's a platform to programmatically and also schedule and monitor workflows. And pretty much is the glue that binds your data ecosystem together. It's open source, it's written in Python, and it was started in 2014 by Max Buchman at Airbnb. There are lots of really interesting projects from that team at that time from Airbnb. You might know as well Superset. Well, there are lots of cool projects from Airbnb. I love them. And the project has been incubating at the Apache Software Foundation since 2016. And I think that a couple of days ago I read that they are kind of graduating at the Apache Software Foundation by next year. That's what they are trying to do. And it's a pretty active project with more than 500 contributors, 5,300 commits, and over 10,000 stars. And this was a tweet from this past week that they were celebrating that they reached that milestone. And there are lots of really big names using Apache Airflow. You might recognize pretty much of them, of course. And what use cases does Apache Airflow serve us? So the main one is it's doing ETL pipelines, but we can do pretty much any kind of pipelines, such as machine learning pipelines, predictive data pipelines, fraud detection, scoring, ranking, classification, recommender system, etc. But any kind of general job scheduling. Imagine that we want to do a DB backup at 2 a.m. in the morning. We could just use Airflow for that. Even at lots of companies, Jenkins, it's being used for those kind of tasks. So Apache Airflow is a best use case. But anything, we could even automate our garage door. So it's kind of an abstract way of dealing with pipelines. So let's check how it works. Airflow uses operators as the fundamental unit abstraction to define tasks, and uses a DAG to define workflows using a set of operators. Hold on, it's pretty easy, you'll see. So this is a DAG. It's a directed acyclic graph. It represents a workflow, which are sets of tasks with a dependency structure, and each node represents some form of data processing. And it does looks like this. It's in this case we have a task. We then have another task called branching that depends on the first task, and then we could go on any of those 4 branches, and we'll just join on the last task. But it could get really complex. This is a live example of a really hard DAG with lots of steps. So, well, let's make our first DAG. So we have 3 tasks that have dependencies between them. We have one called print_bus, sleep, and print_python. And this is how it looks like using Python. DAGs are defined using Python. So we just enter the DAG, we give the DAG a name, and schedule interval. In this case, this is going to run on a weekly basis. And then we just define the 3 tasks, print_bus, sleep, and print_python. So as you can see, the first 2 tasks are using bus, what's called bus operator. The first one just does an echo command, and the other one just sleeps. And the last one, it's a Python operator that calls Python code in this case, What this DAG does, it's just printing hello, commit conf, whatever, sleep, and then print Python. And on the last line, we just manage the dependencies between them. And we then have a nice Airflow UI. It's powered by Flask, we'll check it later. But we can see that there we have our DAG, commit_DAG. The schedule is weekly, I'm the owner, and the tasks. And we have lots of different links to introspect the task itself. But it could get really complex. In this case, we have a list of DAGs. We could check the schedule, the recent tasks. So we have pretty much an overload of our whole data pipeline. We have lots of different views or ways to introspect our DAG. Here have the what's called the graph view with the dependencies. It could get really complex. And we could just check what has happened to any task. We could check the details of the task, the instance. We could check the log of that task at any time. We could just run it again. We could just run that task again, and all the upstream dependencies or downstream dependencies or mark it as success or failure. We'll check it later. Here we have the tree view. So in this case, the task that we have done earlier has been running for 4 weeks, and it went well, but we could just repeat it from any point. This is a more complex tree view of an existing DAG. And we can even see some failures in the beginning. And we have a really useful and handy Gantt view. So we get to know how much time has any task been running for. In this case, our sleep task from the beginning took 6 seconds. Well, okay, some overhead there. But it could be very handy, for example, for longer tasks that have lots of dependencies. So we could see which processes are overlapping, or if they are taking more time over time. So we will see how it's growing over time, any of our DAGs. So let's speak about operators. We know what's an operator already. So let's check which kind of operators Airflow offers to us. We have action operators that performs an action locally or an external system at any third party. We have transfer operators that moves data from one system to another. Sensor operators, that's pretty cool actually, that waits for and detect any criteria and waits for it. We'll check some samples right now. So those are action operators. It just executes code such as a Python function, or it could just submit a Spark job. And we have lots of built-in action operators such as Bash operator, Python operator, Docker operator, email operator, a Slack operator. There are tons of them. And we have lots of community-contributed operators from big players such as Databricks, AWS, and GCP. We'll talk about GCP later. Transfer operators, so we could just move data between systems. Example, moving data from Hive to MySQL or from S3 to Hive. And we have as well lots of built-in operators, Hive to MySQL transfer, S3 to Hive transfer, and community-contributed ones. And this is the really cool part, sensor operators. This is kind of hard to explain, but triggers downstream tasks in the dependency graph. So pretty much, it's a task that waits for a certain criteria, and when that criteria is met, it just keeps running the rest of the tasks. So for example, we could just wait for a file to be available on S3. So if we have that file on S3, keep running the whole DAG. And so we have lots of built-in ones as well. Hive partition sensor, HTTP sensor. We could call any external API and check for a condition to run the rest of the DAG. We have SQL sensor, FTP sensor, and of course the community contributed ones, such as do we have anything available at Google Cloud Storage, for example. That's already built in by the guys at GCP. So let's do a really more complex example rather than just printing functions and sleeping. So let's wait for a key on S3 to be present on a given bucket. Let's create a new AWS Athena partition. Athena, it's kind of Presto as a service from Amazon. We could run a AWS Glue job and wait until it's done. AWS Glue, it's a Spark cluster serverless offered by Amazon. And then notify the team. In this case, data services channel we're using Microsoft Teams, but we could use the Slack operator in case you are using Slack at your company. So we have already all the operators needed for doing so. S3 key sensor, Athena query operator, Glue schedule job operator, Glue job sensor, and Microsoft Teams webhook operator. Some of them I have write those myself at Idealista. We're thinking about open sourcing some of those operators. But it's been a matter of a couple of days, just knowing how to implement operators and plugins, so it's quite easy. And this is pretty much all the code that we need for performing such task. So we have an S3 key sensor. We give it a bucket name, the key, and you might see that we are using a template system. So that template gets rendered on execution time, and all the variables are given on execution time. So in this case, we have a variable available called execution date that gives us the execution date of that DAG. Why? Because we could retry a task or a DAG in the past, and it will just give the date that belongs to. Then we have the update row partition, the glue of schedule, the glue of sensor, etc. And on the last lines, we have the dependencies between all of those tasks. And I think it's pretty cool to do such a huge data pipeline with just given the small count of lines. And Airflow allows us to do lots of cool stuff, such as imagine that we've been using Apache Airflow, and one of the steps was an ETL script that has been running for weeks, and we didn't know until yesterday, but we introduced a bug 3 months ago or whatever. So with Airflow, it's really easy to just log into the Airflow UI and just rerun, I call this time traveling, rerun the related tasks downstream. So we could retry, but we don't need to retry the whole DAG, but just the part of the graph of the DAG that needs to be run again. So in this case, we will just run the ETL step and their children, but not the whole DAG. We don't need to do so. And we call this backfilling. And it's safe to say that if we do our tasks in a side effects-free way, we could just retry any task without having side effects. So I could just retry all the DAGs from the last 3 months, and I'm OK with that. So how everything fits together. This is the big picture. We have 3 ways of accessing or interacting with Airflow. The UI, it's a web server, the CLI, the REST API, and all of these 3 ways of interacting with Apache Airflow. All the state of the DAGs, the tasks, the dependencies, etc., are stored on a metadata DB that could be anything from Postgres, MySQL, whatever is compatible with SQL Alchemy. And then we have a process that schedules the DAGs and the tasks. Of course, the data is stored at the metadata DB. And we have just an array of workers. It scales in an horizontal way. We check how this works. So we have the web servers that's written in Python using Flask. The scheduler, it's just a Python process who is responsible for scheduling jobs. And then we have lots of different executors. The most popular one is Celery. It's a Python library to run task queue, tasks based on a queue. But we have lots of different executors. We could run our tasks on a Mesos cluster, and the Apache Airflow project has got a Kubernetes executor lately, so we could just run all of our tasks in Kubernetes and the metadata database. So the interfaces are those three. The web server UI, we have seen already how does that work, the CLI, and the REST API server. So we could just run any kind of command. So we could just start the web server, the scheduler. We could do lots of meta operations on top of the metadata DB. We could just operate on DAGs. Then you have even a backfill command. So you could just backfill from the command lines, and lots of commands for development and testing purposes. So the web server, as you might already know, you could just have a quick look into DAGs and task progress, check for error logging. All the errors are unified at Airflow UI. And you can browse the metadata. We'll check what's XCOM variables and SLAs, what they are later, and check for historical stats. So this is one question that lots of people ask when they are checking Airflow. How do we move data between tasks? Well, Airflow is not built for moving data between operators or between tasks. In theory, all the data processing should happen in any other service. And Airflow only contains the necessary metadata just for running the downstream tasks. So that means that we have to store on S3 the stage files that we need to run the next task. But at Airflow, we don't store data that the next task uses. We could just move the location of an S3 bucket to the next task that, and that way the next task will just check for the data necessary to run. So we have this metadata storage. We have variables that those are static values, config values, API keys. We could just store them on the Apache Airflow metadata database and use it on the template system while writing the DAGs. We have XCOMs. This is how tasks communicate between them. It's just a small JSON, perhaps, that you could pass along between tasks. So imagine you have a sensor that waits for an S3 bucket to be available. A good example will be that that sensor returns an XCOM to the next task, just stating where that S3 bucket has been found. And connections, we could just store JDBCs out. So we don't need to store all that data while writing tasks, but we access it via the template engine. It does have lots of batteries included, such as failure handling and monitoring. So it retries tasks by default. It also could have more complex retry policies, such as backups. SLAs, that means server level agreements. So if we have a contract kind of with any team at our company and we said, okay, this DAG is going to run for 10 hours, and that's the limit, we could get alerts if service level agreements, it's called, if that DAG has been running for a long time and we don't comply with our internal contract. Smarter cron, we could define tasks using cron syntax, but as it's done in a programmatic way, we could add a Python code to check when the DAG needs to run. So we could add complex code for even checking if it's an even day and off day, or call an external API to know if the market is open and we need to gather, I don't know, cryptocurrencies or whatever. Lots of different complex dependencies, such as only run these tasks if the rest of the tasks have failed. Backfills, we already know about that. and a really powerful template system called Jinja. Jinja is the library used in Python, so if you know the Python ecosystem, Jinja now is kind of the de facto template engine. So I'm going to speak a bit about best practices. So what are the best practices? So idempotency, we'll talk about this later. Logs can be piped to a remote storage, so logs can be stored at S3 or Google Cloud Storage. Backup retries, that means that it retries, but it keeps adding more time between retries. And a good practice, at least for me, is to stage transformed data. So I could repeat any task, and that's not a problem because the necessary data is already stored at S3, and I could run it safely without having to rerun the whole DAG. So recipes. So we could generate dynamic DAGs. This is kind of a hack, actually. So we already know that DAGs are writing using Python, and Airflow checks every Python file available in the DAG folder and registers any DAG variable that is defined in the global space, such as this. So in this case, we are just creating 10 DAGs on the fly. So I don't know how many of you have been already working with Apache Airflow, but this is really cool. You could generate dynamic DAGs from a variable value, a static file. For example, at Idealista, we use YAML files to create DAGs. So imagine that we need to gather data from a source. We have defined all the variables or all the metadata necessary at a YAML file, and lots of YAML files, and the DAGs are created dynamically, or just an external source system. And I want to tell you about data engineering a bit, because I think that Airflow empowers data engineers. Let's check it. So does anybody know about Maslow's hierarchy of needs? Cool, at least one person. But pretty much is we have the data science hierarchy of needs. And this is at some blog post, they call this the hiring out of order problem, because companies are focused on hiring data scientists, and they just have their 80% of their time, they are just performing data cleaning, etc. And there is this kind of new role called data engineer, and we need to care about what I call data literacy, collection, and infrastructure. And it's a role whose mission is just to design, build, and maintain data warehouses. Data warehouses is a place where raw data is transformed and stored in queryable forms. That means that we store the data sets necessary for the whole company, and any worker at the company could just have access to those data sets. Let it be the business intelligence team or the data scientist team or whatever. But pretty much our role is to enable higher level analytics, be it business intelligence, online experimentation, or machine learning. And we have some key skills in order to be data engineers. So we need to master SQL. So if English is the language of business, SQL is the language of data. That's mandatory. We have to know about the best practices while dealing with data. That means load data incrementally, process historic data, backfilling. And as you could think, Airflow allows us to do load backfilling, load data incrementally, so it's a perfect match for a data engineering role. Partition ingested data and enforce the idempotency constraint. So, can't see the forest for the trees. What does that mean? That anyone could use Apache Airflow, but it's really hard to get what are the best practices on how to deal with all those problems, such as idempotency, partition ingested data, etc. This is Airflow empowers data engineers and allows us what I call functional data engineering. That means that we have reproducible, deterministic, and idempotent data pipelines. We could run the task for any date. It will produce the same output. No side effects. future-proof, backfilling, versioning. So if we have introduced any kind of bug, we can just repair it by rerunning the new code, either by clearing tasks or doing backfills. And this is how a common ETL process will look like using Apache Airflow. So the extract part, we have sensors that waits for data. We transfer it. We do some action on that data. It could be a Spark job, for example. And then we have another transfer or a sensor to check if the file has been processed correctly. Well, this is the same. And well, at Idealista, we have deployed Airflow internally using Ansible. There we have the Ansible roles if you want to check it or you want to use those at your company. But there are lots of other options, such as Astronomer. This is a software as a service for Airflow. And this was a really big move from the people of Google. They launched Google Cloud Composer, and it's Airflow as a service, pretty much. It's a bit expensive, but I think it's worth. And the good thing is that they put lots of resources into building all the necessary operators for dealing with the whole GCP platform. So you need to perform a query to build query. There is an operator for that. You need to check Google Cloud Storage. There is an operator for that. They have done all the necessary operators for dealing with the whole Google Cloud platform. What do we do at Idealista with Airflow? Well, we do lots of different stuff, pretty much data pipelines, data ingestion. And we do deployment beyond the Ansible role. We have developed internally plugins for dealing with AWS Glue and AWS Athena. We have developed as well a Microsoft Teams plugin that's the same as Slack, but for Microsoft. And AWS S3 to FTP sync operator. I don't know if we are going to open source any kind of those plugins, but if you need any of those, just ask me and we'll check. And well, this is it. I hope you enjoyed it. And if you have any question for me, I'll be happy.
Yeah, thank you very much for this presentation. Was lovely. And yeah, I'm just working a lot with Spark, and I'm a little concerned on how deeply can it be integrated, all these things of Airflow. I'm not familiar with Airflow myself. And I would like to know if different operators could share the same Spark context.
No.
I think it's against the good practice.
To be honest, what I will do is, so pretty much how Airflow works with Spark, it has a Spark submit job operator. So it just uses the same command line Spark submit command underneath. And you can just send it to Amazon, AWS, or GCP in case that you're using any of those. But what I will do is just to separate that into different steps and save all the necessary data between those steps on any intermediate storage such as S3. And I think that will be that's how I will deal with Apache Spark using Airflow.
Okay, great, thanks.
Hi. Sorry. Thank you for your presentation. Just a very quick question. Does it integrate with Apache Kafka?
No.
No? Thanks.
I don't think so. This is not intended for real-time stream. This is rather more for batch jobs. But I don't know, if you just have a schedule where at a given hour you check for all the logs that are at Kafka, you could just write a Kafka operator that retrieves all the data and just operate on top of that. But it's not intended for real-time processing.
Okay, thanks.
Okay, so thanks.